Lesson 3.4, Parallel and Perpendicular Lines. So in this lesson, we're going to look at relationships between two lines to a third line and decide whether the two lines are either going to be parallel or perpendicular to each other. Perpendicular lines are two lines that intersect to form right angles. The symbol looks like an upside down T, means is perpendicular to. So when you see this upside down T symbol, that's telling you that two lines are meeting at right angles. So let's look at our first theorem. Theorem 3.8. If two lines are parallel to the same line, then they are parallel to each other. So this is kind of like the transitive property of equality. If A was equal to B and B was equal to C, then we knew that A was equal to C. Well, the same principle, if A is parallel to B and B is parallel to C, then we know that A is parallel to C. So in Theorem 9, in a plane, if two lines are perpendicular to the same line, then they're parallel to each other. So if line M is perpendicular to line T, and line N is also perpendicular to line T, then line M is parallel to line N. Notice that the little right angle symbol here, they're both in the corresponding position. Now, it just happens to be written like this because the right angle, if there's one right angle, there's four right angles around this. So there'd be four right angles here, there's four right angles right around here, but they're only going to put one symbol. But these would be corresponding angles. And if we look at the converse of the corresponding angles theorem, say that if we have a pair of corresponding angles that are congruent, then our lines are parallel. So for the same reason, these are perpendicular to the same line, so therefore they are parallel. So let's look at what happens when we solve a problem with parallel lines. So we're given an example like this. We have this figure. And ask us, what is the relationship between segments AB and CD? So are they parallel? Are they perpendicular to one another? So we have AB and we have CD. So let's look to see how we can figure this out. So if I look at these two angles here, this is 68 from here to here, this is 22 from here to here, this is 35, and this is 55. Well, in order for these to be parallel, they'd have to be same side interior angles. So let's see what this whole measure is from here all the way from here to here. So that means I'm going to take 22 plus 68. If you add those up, it gives us 90 degrees. Now let's take a look at this side. If I take 35 plus 55, that also gives me 90 degrees. So that means I have a right angle here and a right angle here. So what this means is I have two lines, AB and CD, that are perpendicular to the same line. So based on our last theorem, that would mean that they would be parallel. So if you have two lines perpendicular to the same line, then they would be parallel. So we would say, to write this out in full, we'd say then, kind of justify it, AB would be perpendicular to BC, and we would say that CD is perpendicular to BC. So AB would be parallel to CD because they are both perpendicular to the same line. Okay, so because these two lines are both perpendicular to the same line, then these two lines are going to become parallel. All right, let's take a look at the next. So what we just looked at, Theorem 3.8 and 3.9 give us conditions that allow us to conclude that lines are parallel. The perpendicular transversal theorem provides a way to conclude that lines are perpendicular. So the perpendicular transversum says this: in a plane, if a line is perpendicular to one of two parallel lines, then it's also perpendicular to the other. So if line N is perpendicular to line L, and we know that line L is parallel to line M, then we know that line N has to be perpendicular to also line M. All right, so the last example here, it asks us to find the relationship between our lines. So for each combination of relationships, tell how A and D are related. So let's look here. A is parallel to B, B is perpendicular to C, and C is perpendicular to D. So the best way to do this is to draw a picture. So the best way to do this is to draw our picture. So let's take each situation and draw them individually. So the first one is that A is parallel to B. So it doesn't really matter how you start your line, but I'm going to start with two lines that are parallel. This one I'm going to name A, this one I'll name B. A parallel to line B. So the next situation, it's going to be B is perpendicular to C. So if I'm going to draw this perpendicular to C, then I have to draw it down through here. So I would say that, call this one C, and I'll show that these two are perpendicular to each other. And so the last one is we're going to see is C, we're going to put C perpendicular to D. Well, if C is going to be perpendicular to D, that means it's got to go in this general direction, which means this will be D, and this will be perpendicular. So, as we look at this, it wants to know what is the relationship between A and D. How are they related? Well, if you look here, we know A is parallel to B. Okay, B is perpendicular to C, which means by our perpendicular transversal theorem, that means that A is also parallel to D. And it means it's also perpendicular to C. So, therefore, these are going to be parallel. So we'd say the answer is going to be A is parallel to D. All right, so let's take a look at the next one. A is perpendicular to B, B is perpendicular to C, and C is parallel to D. So find the relationship between A and D. Best way to do it is to draw your picture. So pause the video and come back and see how you did. All right, so let's look here. We have A perpendicular to B. We have B perpendicular to C. So if they're both perpendicular to the same line, then these would be parallel. That means what A and C would be parallel. And since D and C are parallel, we could, if the same line's parallel to the same line, then we're going to have all three parallel. So this will be A is going to once again be parallel to D. So they're not always going to end up always A parallel to D, but the best way to do it is to draw a picture of each situation and make sure you label it, mark it, and then you can determine at the very end what that relationship is from line A to line D. All right, that concludes lesson 3.4.